Let's say you are running a company and you have the opportunity to buy a machine. How do you make that decision? The decision, like anything else in life, comes down to are the benefits greater than the cost? But in a finance context, how do we do that? Well, we need to estimate cash flows, because I don't care what this machine makes. This is a money machine. So I need to draw a timeline and say, what is this machine going to produce for me? Not what product will it produce, but what money will it produce and when will it produce it. Both of those, the size and the timing, are important, and so is the risk. So I need to come up with the size, timing, and risk of these cash flows. So when I estimate that this machine is going to produce positive cash flows of $500 in year 1, 2, and 3. I'm going to say K is my discount rate. I'm going to call that my cost of capital. And based on the risk of this machine actually working the way I think it will, I think that discount rate needs to be 12%. So now you know how to get the present value of these. You say $500 divided by 1.12 to the first plus $500 divided by 1.12 squared plus $500 divided by 1.12 cubed. I want you to look at this. You already know how to do it, but look at that equation, and you know the present value of the benefits is $1,200.92. So now you know you're willing to pay that much for the machine. Somebody, the salesman, says, well, this machine will cost you $1,000 today. This is great. Now we know what I want to call the net present value of the machine. That's the main thing we want to look at next, is the net present value, or the NPV, of different projects. So the NPV of this project is going to be, I'm subtracting the amount it costs today, the $1,000, and I'm adding the future benefits, the positive cash flow of 500 divided by 1.1, because I have to get the present value of it. So I'm going to write this out here. And the way we're going to have almost all of these set up in kind of this classroom, somewhat simple world, is you're going to have a machine, or you're buying plant, property, or equipment, whatever it is you're doing, is going to cost you some money today, and it's going to generate some money in the future. You're going to have to estimate what that money is. You're going to have to estimate the appropriate cost, so you have to get the size, timing, and risk of the cash flows. Before we go into those estimations, I want to make sure you know the rules. Once we know the size and timing of the cash flows, once we know the risk of the cash flows, we can find the net present value. The net present value in this case is $200.92. So if we do this project, we've increased the value of the firm by $200.92. That's an important point I want you to get. Doing this project increases the value of the firm by $200.92. And our goal is to maximize shareholder wealth. So by doing this project, we are increasing shareholder wealth. And if this is the only project we have a chance to do, we're maximizing shareholder wealth. Now let's look at a couple other things. Well, let me go back. The rule that I want you to know, if the net present value, so here's the rule, if the net present value is greater than 0, I accept the project because it increases the value of my firm. If the net present value is less than 0, I reject the project because it decreases the value of my firm. If the net present value is equal to 0, I don't care because it doesn't increase or decrease the value of my firm. Let's start with looking at the assumptions. We're assuming the appropriate discount rate is 12%. What if we're wrong? What if it's really 15%? So what if instead of that being a 12, those should have been 15s? What would have happened? The net present value wouldn't have been $200. It would have been $141.61. So I want to find what value makes net present value 0, and here's why. As long as I know the discount rate is below 12%, I'm okay, because if interest rates go down, present values go up. But if interest rates go up, present values go down. So if I increase this, what if I'm wrong? What if it's not 12, it's 15, I'm still okay. Well, what if it was 18, am I still okay? So what I want to do next is say, I want to set the net present value equal to 0. This is where I don't care if I do the project or not. And I want to do this math again. 500 divided by 1 plus, I'm going to call this IRR for internal rate of return. So I take these three, 1 plus IRR squared, and I'm looking for this number that's going to make net present value equal to 0. I don't want you to worry about doing this in a calculator yet. I just want you to get the point of what we're doing, and we can teach the calculator to do it later. So if I solve for this, and by the way, you can't do it without a calculator. You can't get internal rate of return on one side and everything else on the other. But if I solve for this, the internal rate of return turns out to be 23.375%. What does that mean? That means as long as my discount rate, or my cost of capital K, is less than a 23.75%, then net present value will be positive. Because if it's 23.375, net present value is 0. Lower the rates, present values go up. So my rule is if the internal rate of return is greater than my cost of capital, I accept the project. Another way to think about that, if my return is greater than my cost, benefits greater than cost, I do it. If the internal rate of return is less than K, then I reject. One assumption here, we're assuming that I can reinvest these cash flows at the internal rate of return, which is not always a great assumption. But the bottom line I want you to think about or take away is this rule always holds, and this rule always holds. There are times that come into conflict, and when they come into conflict, net present value is the one we go by, but we will deal with those a little bit later on. Now let's look at a couple other rules. Let me move this up and go back here and draw this timeline again. So you're paying $1,000 today, you're getting $500 in year 1, year 2, and year 3. The next rule I have, I'm going to call this the profitability index. So profitability index, which I'll write PI for short. PI is going to be the present value of the benefits. I can't even spell benefits, so it's going to be the present value of the benefits over the present value of the cost. So in this case, the present value of the benefits were $1,200.92. The cost was $1,000. So my profitability index was 1.200. I'm sorry, I did that wrong. 1.20092. As long as the profitability index is greater than 1, the benefits are more than the cost, and I accept. If the profitability index is less than 1, the cost would be greater than the benefits, and I reject. Okay, another way to write this, the profitability index is equal to the net present value plus the cost divided by the cost. I can do this because we're always saying the costs come in year 0, as long as I'm making that assumption. And then I know that the net present value is equal to minus the cost plus the present value of the benefits. So you can look at this basic equation, and what this tells you is dollar for dollar which project gives you the most bang for your buck. So if I'm investing $1,000 or $10,000 or $100,000 or $1 million, however much that is, of course the $1 million project will probably give me a bigger net present value than the $1,000 project, right? Just because of the size. But we want to look dollar for dollar which one gives you the most bang for the buck. Okay, let's look at two other and these two other rules, and this is not as important, the payback rule. I just want you to know this rule because it exists, and I want you to know some of the flaws with it. So let's do it like this. Let's move this off to do the payback rule. Let's look at two projects. We'll have the blue project, and we'll start with it, the same thing we had before. Here's time 0 minus $1,000, time 1, time 2, time 3, $500 each. The payback is 2 years. I spend $1,000. It takes me 2 years to get that $1,000 back. One thing about the payback rule is I don't know, is 2 years good? Is 3 years good? Is 4? Is 5? There's no rule. There's nothing that says that if the net present value is greater than 0, accept. I don't have a firm accept reject rule. The others, it doesn't take into account the time value of money. So I know that's a problem. But here I think is even the bigger problem. Say you have a choice between the blue project and the red project. Which one would you choose? So they're identical the first 2 years, with paying $500 and $500. But in year 3, the red project pays you $10 million. You don't need a finance class or a video for this. Would you rather have the blue project or the red project? They both have a payback period of 2 years, but everybody would rather have the red project, right? So the other problem with the payback rule is it doesn't account for anything that happens after the payback. Okay, so that's a little bit of trouble. Let's look back at this. Let me get this erased real quick. Just get this out of the way. So let's look back at this rule. I want to have what I'm going to call the discounted payback. Like I said, the payback rule doesn't take into account the time value of money, the present value. So I look at the discounted payback, and what I'm going to do is the 500 divided by 1.12 to the first, this 500 divided by 1.12 squared, and this divided by 1.12 cubed. So what I'll wind up here is something that looks like this, where I have a timeline with all present values. That's the 1,000. This would be 446.43. In year 2, that's going to be 398.60. See, I'm just doing the math from here. In year 3, doing this math, it's 355.89. Now, how long does it take me to get my $1,000 back? Well, after 2 years, I now have 845.03. So adding these two numbers together, 845.03, I still need to get 154.97. So to get back to 1,000, I need another 154.97. In year 3, I get this amount to 355. So 154.97 over 355.89 is equal to 0.44. So my payback, my discount payback, is 2.44 years. Okay, that's it. Quick review. What really matters is the net present value. Make sure you really understand that one. And whatever the net present value is, that adds that amount or subtracts that amount to the value of the firm. So you want it to be positive. Next to net present value, the most important is internal rate of return. We will deal with profitability index in a little more detail in other settings. And then the payback rule and discount payback, I just want you to be aware of them and their weaknesses.